Hello everyone. During JOSAA counseling, many students exercise their options for the various departments without really having proper information. They often base their choices based on some kind of unreliable information from scattered bits or from hearsay, or sometimes, very unfortunately, based simply on guesswork. So in this situation, I thought it would be a good idea if we can have some proper information from reliable sources so that the students can exercise an informed decision. So in this series of video, we have already covered aerospace engineering and mining engineering, and today we are going to cover chemical engineering. And for that, we have with us Professor Sunando DasGupta from the Department of Chemical Engineering at IIT Kharagpur. So welcome, sir, very much to this new series of videos, and thank you very much for agreeing to this interview.
Thank you, Professor Chakraborty. I think what you are doing is wonderful. I hope it's going to be helpful to the students and to their parents who sometimes put undue weightage on the streams that their daughters and sons are getting into. And this series which you have created, I think would dispel some of the myths about what is going to be the so-called in department and which departments are not so lucrative. What I want to emphasize at the beginning itself, that there is nothing like a department which in itself is going to decide on the future of the prospective students. It is entirely on the student how he or she is going to apply herself in learning something new and try to figure out which is going to be her liking in which area of the engineering based on her fundamental training in, let's say, chemical engineering. She would like to venture out in different areas. So we are not going to learn a specific engineering. What I would want, or all faculty of chemical engineering, in fact, all faculty of IIT would want, is the students to learn how to learn a subject. The technique of learning is important, not what exactly you are learning. That is definitely important. But the way you can master a new field, that will be helpful. That will be with you for the rest of your life. Because whatever you do, you are not going to be bound to the discipline to which you are entering. It's the idea of learning. It's the idea of what you have learned and applying it to a different field. Because what we see today is that our scenario is changing and we are getting more and more diverse. And we have to pick up certain things which are to our liking or whatever opportunity presents itself to us. So in that situation, if we know how to learn new things, that's going to be very important. So Professor Chakraborty, I really congratulate you in doing something unique, and it's going to definitely help some of the students. What I also understand is that the decision has already been made by the students and sometimes their parents based on, as you have mentioned, a number of sources, a number of trains which are present in which are basically you would get from everywhere, from your seniors, from your teachers, from a friend of friends, or from your neighbors. These are important because they are inputs. But many of you are going to be interested in, let's say, machine learning, artificial intelligence, and so on. So all these inputs are not going to be equally important in order to decide where you want to go. So how to filter out those information and get the right one, which would make you, which can allow you to make the right choice, that is important. So in this regard, I understand that Professor Chakraborty, we are going to have a discussion. It's not going to be a one-way street. We'll have a discussion. And from that discussion, I think I would like to point out what chemical engineering is all about, and that if you have chosen chemical engineering or chemical engineering is the only choice that you're left with you, you haven't made a mistake. So what is there in chemical engineering that should interest an intelligent student like you? That is going to be important. And I would like to emphasize that in today's discussion. Professor Chakraborty, you
Thank,
have some other
thank you.
points.
Wonderful input. Wonderful input. Thank you, sir. So let us start specifically with chemical engineering now. So my first question would be, sir, what is chemical engineering all about, and what are the broad areas within this discipline of chemical engineering?
I am saying this not because I am a chemical engineer, but there are very few things in your daily life which are not impacted by chemical engineering. Let's say the screen that you are looking at right now, that screen, when it was made, chemical engineering, materials, chemistry, physics, all played a major role in fabricating such screens. So the application of chemical engineering is versatile. You can think of chemical engineer as someone who's by profession works in a refinery. So petroleum refining, petrochemicals, that's going to be a major role, a major part of our training as chemical engineers. We are also, there is another part of chemical engineering which looks at pharmaceuticals. So the pharmaceuticals, the drug making, the drug delivery, and the associated biology and chemistry, that's going to be very important for a chemical engineer. We also understand the role the environment plays in our lives. And I am recording in this with a temperature outside which is close to 40 degrees with a humidity of about 75%. So it's extremely, this is going to be, this is a major part of our daily life. So how to take care of environment, the pollution, the control of the effluent, the cleaning of the effluent, the refining of the effluent, these are a major part of a chemical engineer's job. The fertilizers, that's also one very traditional area in which chemical engineers have played a major role. And finally, I would also like to talk about batteries, energy, the materials of the battery, the rechargeable battery, the cathodic and anodic materials. Now the emphasis is going towards solid batteries, solid electrolyte batteries. Who is going to design that? An electrical engineer can talk about the charging strategy, but it is the chemical engineers who has to come up with something, some solid material, which is going to give us fast charging. It's going to retain the charge for a longer time, and the formation of, let's say, for example, the dendrites, which take place whenever you are charging or overcharging, and create problems for the battery. So all these energy related, including the solar panels, which we see every day around us. Whenever you see a solar panel from now on, think that you as a chemical engineer will have a role in that. So if I have to summarize my answer to your query about the broad divisions, it's going to be in energy, petrochemicals, petroleum, materials, electronics, and various other pharmaceutical industries where our job, where our training grounded on physics, chemistry, mathematics, and biology are going to be very important. So as you can see now that it is easy for us chemical engineers to go from one field to the other. I know Professor Chakraborty is a mechanical engineer, and I can challenge him that a mechanical engineer would not be as versatile as a chemical engineer. But that's a separate point in which we can debate later. But I just make a statement to emphasize that it is something which gives you the opportunity to venture out into different fields.
Thank you, sir. So I have been working for the past few years on batteries, and I can attest to the fact what sir has mentioned just now, that chemical engineers and chemical engineering scientists have made some absolutely fundamental contributions in this area. So both in terms of the material science aspects as well as in the design aspects of the next generation batteries. Yes. So thank you for pointing that out. It's an absolutely active area of research nowadays. And India is putting a major thrust in the development of this technology in the coming 5 to 10 years, and
Absolutely.
even beyond that. So thank you very much for pointing that out particularly. So my next question is that so when the students are choosing the department, sure, they can read up about the various things, but it would be great if they can match up their own academic interests or their temperaments with the department. That would be a golden match. So what would you think would be the right temperament for a student to have for them to be properly suitable for the chemical engineering department?
I think the kind of students who are going to excel uh, in any engineering branch, and chemical engineering is no exception, that we are looking for students who are willing to learn new concepts by extending their skills in the basic subjects that they have learned in their +2 level. So it is the physics, the chemistry, mathematics, and biology is becoming more and more important these days in many engineering disciplines, and chemical engineering is no exception. So if I, as a student, uh, am confident about the concepts that I have learned, so this department is going to give her the opportunity to figure out where those concepts can be applied in real applications. So someone who's very good in physics, the role he can play in the let's say for material science. Okay, you are making a new material for a solar panel. That is going to be of vital importance. Someone who is good in chemistry, the solid electrolyte, as Professor Chakraborty, as you have mentioned, that is going to be extremely, I would say, relevant. Someone who is good in mathematics, the control of these process plants will require a strategy that is grounded in mathematical modeling of the system. So a series of system equations are to be solved in order to arrive at the optimum operating condition of a petrochemical plant or a pharmaceutical unit or an effluent treatment plant. So someone who is good in mathematics, it would be easier for her to pick up the pieces and connect them through the common thread of mathematically expressing it. And therefore, as my point is, it is not any one subject which is going to be important. It is all three of these subjects, including biology. I should definitely mention biology. These four subjects are going to play a vital role in chemical engineering, especially because the application domain of chemical engineering is so vast. So if you are good in one of these subjects, we would like to have you good in all these subjects. But if you have a particular fascination for a specific subject, then you will find enough applications of that in practice. So that's the, I would say, the advantage of chemical engineering or someone with a chemical engineering background.
So I think this would be a right time to dispel a notion which many students often have, that if they are good in chemistry, it is only then and then only that they'll be able to do well in chemical engineering just because the department's name has the word chemical. Probably that is not true.
Absolutely.
They need to be strong in physics, and if they are strong in physics, probably there are more than enough avenues for them to excel and chart out a brilliant career within chemical engineering.
There used to be a faculty at MIT a long time back when we were students, and he came to India for a conference.
Okay.
And what he said, I still remember that, is a chemical engineer is one who talks about engineering in front of chemists and chemistry in front of engineers. So that is very true. I mean, we have chemical, so people will often associate chemistry with it. Yes, chemistry plays an important role, but it's not the only one. And if you think in a very philosophical way, at some point of time, all these disciplines merge, the basic question that comes to our mind is why? Why this is happening? So if you see a new phenomenon, you try to think about why this is happening. Is there any way to explain this? Is there any way to create conditions for it to move further? Now, these inputs can come not only from chemistry, but from any branch of basic science. So you are going into engineering. The students are getting into engineering, but do not forget your basic science. Because that is where most of your inputs for solving real life problems will come. So talk chemistry in front of other engineers, and definitely talk engineering in front of chemists. We rely heavily on chemists, chemistry knowledge, because it's the physical chemistry which often merges with physics, the statistical mechanics part, the physical chemistry, the organic chemistry. All of them play a role, but everything has to be supported by physics and mathematics. And for the case of pharmaceutical, it is biology that is important. So it is a myth, and do not rely on that. Do not think that chemistry and chemical engineering are same. They are very different.
Thank you, sir. Thank you for dispelling that notion. So the next natural question is that, fine, this is the motivating things that students need to keep in mind when they're exercising their choice. Now, once they come to the department, what kind of fundamental courses do they undergo, especially at the second year, third year level, which builds up the absolute basics of the discipline? What are the kinds of things that they study?
Okay. The first courses that they would study deal with the transfer process. We are transporting heat. We are transporting mass. We are transporting momentum. So it is the fluid mechanics.
I'll just stop you for a second for a little bit of a piece of information. So students, if you're listening to this, please make a proper record of what Professor DasGupta is saying, because he has been a legendary professor in the discipline that he's now currently mentioning, transport phenomena. So please mark his words very, very carefully.
The Professor Chakraborty is too kind. I am just a teacher like everybody else in this system. So what I try to think is that there are many courses in chemical engineering which are going to be important, but there has to be a stream which is going to attach all these courses together and point out the commonality in between them. So I start with, as Professor Chakraborty said, is my which I'm just trying to teach for the past few years, is the transport process. What is a transport process? It can either be heat transfer, which we come across every day. How do we make heat transfer between a cold fluid and a hot fluid? What kind of equipment that are needed? What are the basic principles of their design and the basic physics? So this course, and then we have the fluid mechanics part. From the first thing that you have done this morning, the students, hopefully, is that you brushed your teeth. So the toothpaste that you have used is a special kind of a fluid. It doesn't flow on its own. You have to put certain amount of pressure, after which it starts to move. So what is going to be the different types of fluids? How do you make them go from one place to another? How the water is going to be pumped from the underground reservoir to the overhead tank? How do you transport crude oil from one point to thousands of kilometers away to a refinery? So this transfer of fluid, the transfer of heat, and then comes the transfer of mass. And once we talk about transfer of mass, it's the interaction, the reactions between different components that are going to be extremely important. So you are designing a reactor where two components come in under certain conditions, they are going to combine and create a desirable product. So what kind of reaction? How do you control the reaction? What is going to be the design feature of that equipment? That is what we try to emphasize through various courses For example, fluid mechanics, to move the fluid and to understand the physics, heat transfer, the mass transfer, and then comes the reaction between the components. So reaction engineering, it's not kinetics, it is engineering, is the one which we would like to teach our students so that they have a fair idea of how to design a reactor. All these processes need certain kind of controlling strategy. How do I control the reaction? And I forgot to mention that chemical engineers also have a lot of jobs and applications in nuclear engineering. So
I'm going to ask that actually.
yes.
Yeah.
So how do you control a nuclear reactor? Because a nuclear reactor is the one in which you have flow, in which you have tremendous amount of heat generated, which has to be extracted for practical applications. There's going to be some amount of mass transfer, reaction, but most importantly, you need to control the reactions in such a way that it is going to be safe. And these days, I think the emphasis is going more towards renewable energy and to some extent green energy. If I consider with the coal burning technology or the petroleum, nuclear is going to be one of the safest option. And only yesterday I was reading that there's a Bill Gates is investing a lot of money into nuclear energy, safe nuclear energy. So the push is again going towards nuclear because of all the other problems associated with the greenhouse gases and so on. So let's come back to what I was talking about, the different subjects. So the process control is another subject which we would like to teach our students, and so that they know the mathematical way of writing the governing equations, see when you have a runaway reaction, whether a process is stable or unstable, the mathematical analysis of that, and design of controllers. So that's another subject which we talk about, which we discuss in chemical engineering. Then comes the environmental issues. The pollution control, that is another fundamental subject of chemical engineering. So what are the different polluting industries? What are the pollutants? How do we control them? How do we reduce them? How do we manage the effluent? That is another subject which is being taught in chemical engineering. And of course, if we have to go back to the fundamentals, nobody can do anything without understanding the thermodynamics. So thermodynamics is the key, I would say, key element in all of these operations that I have discussed about. So one has to have a very good fundamentals about thermodynamics, and that is another major subject in chemical engineering. A host of elective subjects depending on what you want to learn. So it could be from computational fluid dynamics to AI application in chemical engineering, or many such areas where the system is getting smaller and smaller, and the small is beautiful. So if we go into the physics of small things, it could be a molecule, it could be combining the molecules in a way such that you get your desired product. So a top-down or a bottom-up approach in order to give you a micro reactor, a micro-scale heat exchange device, or a microscopic motion control of microscopic motion of the bacteria or the cells, in order to obtain something which is desirable. So many of the detection techniques, the disease detection, they require, today's thrust is going towards using smaller reagent, getting a signal. It could be a colorimetric analysis, it could be an impedance, and designing such systems. So there are a number of such elective subjects where the students can choose based on her aptitude and her interest. So these are, in a nutshell, what we try to teach in chemical engineering.
Thank you, sir. And just to add to the point, because from my own experiences during my PhD, I noticed that there is a lot of overlap or intersection between what I was doing and what the chemical engineering people were doing. I noticed that there is a lot of mathematics involved. And later on, when I went on to do my postdoc, I saw that a lot of the people, incidentally, I had done my postdoc in a mathematics institute. So uh, I noticed that a lot of the applied mathematicians, they are working on problems which had direct applications or when motivated by various areas within chemical engineering. So people who are intrinsically interested in the mathematics, they can actually think seriously about choosing chemical engineering. They'll have lots of opportunities to really excel here.
Absolutely true. It's good that you have mentioned it. We also have a course of advanced mathematical techniques in chemical engineering, apart from the basic mathematics subjects that all students will have to learn. So just take a small example of application of mathematics in chemical engineering. Let's speak the mixing. You're mixing two materials. So what kind of, how you would like to create chaos, you'd like to create turbulence such that the mixing gets better. So what are the conditions, what are the equations that need to be taken into account and to be solved before you can correlate the quality of mixing with the turbulence produced, and then apply it back to the design of the different nozzles which are to be used for proper mixing. So these are extremely important applications of mathematics. Just one example of mathematics in chemical engineering. So in heat transfer, in mass transfer, and in fluid mechanics, there is a lot of mathematics, application of mathematics, apart from the process control part that I have just mentioned. And also, if there are a number of reactions which are going on in parallel, you'd like to increase the yield of the desired product. So the mathematical modeling of these reactions and how do they depend on the conditions, and what it's an interrelated problem of heat, mass, momentum, reaction, and so on. So application of mathematics in all these, someone who loves mathematics will get enough opportunity to explore areas inside chemical engineering.
Absolutely. And touching upon a related area, so there are students who are becoming increasingly interested in programming right from their school days. So I believe in chemical engineering also, once they get into some kind of a research project, uh, there is a lot of opportunity for doing coding, for numerical techniques. So could you please elaborate a little bit on that?
The previous example that I have given, I was discussing the mathematical modeling of a system. You need to solve it. You need to write a code.
Yes.
I know that you are very good in computational fluid mechanics. You work in that area. So many times the codes that you have, and the real system in which you would like to solve, they're different. So you have to modify or write your own code. So that is an excellent application of your ability of coding a problem in order to get a solution. So the coding is going to be it is already an integral part of any engineering, and chemical engineering is no exception. So you need to know how to numerically solve a number of differential equations, coupled differential equations, could also be partial differential equations, and you need to code. And there are different ways of optimizing. How do you optimize the desired one? And when you have the objective function of the optimization routine that you have created based on your fundamental understanding, you still need to write a code. And there are situations, I guess we are going to discuss it separately later on, the use of AI and so on in chemical engineering. Maybe I can just elaborate because these two are related ones, the coding and the AI and so on. I remember that a few years back, two of my colleagues, my co-workers, the faculty members of this department, they were collaborating with, they were working with a petroleum industry. And you know how you probably have some idea, you may have seen, the students may have seen the huge petrochemical complexes that you may have gone, you have passed by them. And from a distillation column, the crude is distilled and to get different products. At the top of the distillation column, you get the purest variety, the gasoline, which is the aviation fuel. And at the bottom part, you get the bitumen and the tar, which we use for putting on the road. And in between, we draw off several components which have different uses. In the normal gasoline that we have is from there. Now, someone was trying to create or try to get an idea of if I change the process condition. For example, the temperature or the pressure or the number of trays in the distillation column, how that affect the property. It is extremely difficult for an industry to change the condition from a set point to see what is going to happen. So you can come up with different ideas, but you do not have the luxury of changing the regular day-to-day operation of a refinery. So they were asked to come up with neural networks based on a huge number of data available to predict what would happen if I change this temperature, if I change this pressure, or if I change this composition. So this huge data, how do you analyze them? How do you come up with the trends? How do you predict what would have happened if you have changed this? That is essentially your machine learning and use of your AI. So this is just one example of how these concepts can become relevant, are relevant in chemical engineering, to predict something without actually doing it. So if we could do that, we would reduce the cost, the time, and the effort. So that's where I think the future lies for many of our present students.
Thank you. Thank you for pointing it out. We'll come back to the discussion of AI on a related point a little bit later. Now, on the flip side of the course work, I would like to point out, I would like to ask you something which many students have in their minds. So, how heavy is the course load in chemical engineering? Will it leave any time for curricular or extracurricular activities or co-curricular activities? So this is something which many students have in their minds. Could you please give us some idea about it?
I think the students who are joining this department are roughly on an average 18 years of age.
Yes.
This is an age where they're at the very impressionable age. And they would like, they see that their seniors are doing certain things and they would also like to follow them. Do as much extracurricular activities that you want, whatever you like. It could be photography, it could be singing, it could be dancing, it could be a debate competition. But one thing one must learn is how to manage your time.
Absolutely.
That is very important. So if you can manage your time, you'd be able to enjoy your days in any engineering institute, in any IIT, in any department. Because the opportunity to excel in fields other than your field of study, to pursue what you like, that is the chances, the avenues are so many. Since the avenues are so many, there is also a flip side of it that you are getting lost. Do not get detached from your fundamentals, from your moorings. Academics is the reason why you are here. But you should, because that builds your interpersonal skills, that builds your character, that gives you the extracurricular activities, give you a way to distress yourself from the academic rigor of an IIT life. So by all means, I would say, go for your extracurricular activities. Do it properly. Whatever your passion is, follow that. But do a proper time management such that you are not going to be too far from your academics and your passion and your study can coexist. There is a symbiotic relationship between them. If you are good in academics and you follow your passion of, let's say, singing, each one of them is complementary. Make that as, because these 4 days, these 4 years are probably the only time when you will have free time to do things that you like. Once you cross this institute, once you graduate, you will hardly find chances, at least in the first 10 years of your career, to pursue what you really liked. So by all means, go for your extracurriculars. And this department or the workload is not going to hinder your interest in those areas that much, I can see. Because I have seen many students who are excellent. And I always feel that those students are more complete as a person. He or she is not just involved in academics, but they have a complete personality that makes them, that they can cope with the stress of the life later on. So that's very important.
And this is something which stays with them all throughout their lives.
Absolutely. Yes. Follow your passion,
Yes.
but do a proper time management.
Right. Now, as you touched upon the professional life, let us segue into that. So what kind of core jobs are there within chemical engineering discipline, and are these available in India?
They are very much available. For example, the areas that I have mentioned: petroleums, petrochemicals, process design, pharmaceuticals, environment, and materials. Now, these are the general areas. Now, let's think about which are the companies that traditionally employ chemical engineers. So I'll start with the oil companies first: Indian Oil, ONGC, the Reliance, the other companies, for example, Engineers India Limited, the consulting companies like McKinsey, they all, the Bechtel and so on, who design the process, who design a chemical plant, they would be looking for graduates, bright graduates from this department. If you think about the pharmaceuticals, there are so many new pharmaceutical companies which come up. The major leaders in Indian context, some of our students, in fact, every year, maybe 5 to 10 students of this department, they go into Dr. Reddy's laboratory. So that's going to be another one who's going to employ our graduates. And a host of other companies who are into materials research, the materials company, the batteries, and so on, they also are prospective employers of this department. And the trend, and besides that, there are a number of other companies who recruit from every department, the banking and the financial sectors. Now, whether or not it is advisable, I mean, that's a personal choice which you have to make, that whether to go into those kind of services, those kind of industries where your specific skills are going to be important, your analytical thinking and your way to project the present into the future, that is going to be important. But no matter what, the basic tenets of your undergraduate education, the one that I started with, you learn how to learn.
Yes.
That remains with you. So even if you go into those fields, how quickly you can adapt to the changed scenario, how quickly you can learn the new things that are prevalent in those companies, that are going to be important. So don't think that just because you have entered mechanical engineering or chemical engineering, that somehow limits you in joining those companies who are recruiting in large numbers. Because I think it's a lifelong exercise for every one of us to keep learning and new things, to make ourselves more valuable in the job market. So this kind of self-improvement goes on throughout our lives. So that would always be good.
I couldn't agree more, sir. Absolutely true. On the professional side, so this is on the industrial side of things. Maybe could you touch upon on the higher studies side of things? So many students, they are a little bit research oriented. They would like to go for higher studies, maybe go into academia, become professors themselves. Could you please give us some idea about what kind of uh, activities are going on at the cutting edge of chemical engineering? You have already touched upon certain things, but maybe we focus here a little bit here.
The first thing that one should have is inquisitive mind. If someone wants to know why something is happening, rather than just reporting it as they see it, they would like to know they would like to go deep and try to find the reasons from first principles, or from the basic physics of the process. They are the ones who are ideally suited for higher studies. And chemical engineering is one discipline. I mentioned this before, that there are various facets of interesting applications that one can find to his or her liking, and then go deep into it. In our department, for example, there are several areas in which we try to expose students to what is happening in today's world. And they can do projects with us on their own interest or as a part of their curriculum. And in there, if they start liking the area, the research, the idea of going beyond what they see, then the opportunities are endless. Many of our graduates, they go into higher studies in the best schools of the world. I think last year, one of my students got into MIT. It is just an example. There are many others who go into the top schools. Now, what they have an intrinsic interest to know the fundamentals, the reasons, and they are willing to spend additional time. They are willing to work hard to get into their dreams. You have to have a passion to go for higher studies. Just because everyone else is doing it, or some of your friends are doing it, that's not sufficient. So if you have that passion, then go for it. Because ultimately, this is truly probably the only area in which you can become independent. You be your own boss. Once you progress in your life, as Professor Chakraborty, you know very well, because you are now following your dreams. And there is no one who tells you that, Professor Chakraborty, you have to do this.
Absolutely true.
It is very true in any academic, in any industrial job, or any other programming job, coding job, banking, anywhere. So if you feel that a career with the ability to do what you like is something that you want, and you are not afraid to ask hard questions and work for it, then yes, higher study is the path for you to follow. And the students that I see from this department going for higher studies in different universities and excelling beyond are many. I have seen many such students. I have the good fortune of interacting many of them during their undergraduate years, even during their PhD and beyond. And this is probably something which it's a bit personal, but I have seen Professor Chakraborty as an undergraduate student, a bit as a PhD student. And when I see him, when I see you now, the way you have matured, that should be an example to many of our students.
Thank you very much, sir.
So that is what, and you are independent.
Yes.
So ask the hard questions. I would say to the students, ask the hard questions. If you feel that is the area in which you would like to get into, by all means, go for higher studies. And since chemical engineering is there are applications that are so many, I'm sure you'll be able to pick up something which you like and then excel in it. I have seen students from this department have done that. And I'm sure some of the students who will be joining this department will continue to do so in the very near future. So
Thank you, sir.
yes.
Thank you. Very nicely put. Very nicely put. If I were a student, I would absolutely veer towards chemical engineering hearing your words.
No. It's ultimately it's a decision which the students will have to make. But whatever be the decisions, whether they make it or it is thrust upon them, there is always something to learn and love in any discipline.
This
Chemical
is
engineering is
this
no
is
exception.
absolutely true. Absolutely true. I couldn't agree more to this. Uh, so, talking about the future and the future prospects and things like that, one cannot steer clear of one looming question, which is the effect of artificial intelligence on a particular discipline. Now, you have already mentioned something related to the research side of things and touched upon a bit on the professional side also. So how do you think artificial intelligence, machine learning, these sort of things are going to affect the industrial side of chemical engineering, industrial jobs, and so on and so forth? I mean, there is no end to the prospects and the bright prospects that the influence of artificial intelligence, machine learning, this sort of things is going to have on the research side. We all agree to that. But on the industrial jobs sort of thing, what do you think would be the uh, future?
Artificial intelligence is something which will be with us for a long time, and it is going to get better and better. Uh, mm, uh, the example that I have given you about predicting the performance of a big industry or an industrial unit without affecting its daily operation.
Yes.
How do you do that if we do not have the machine learning? If we cannot read the trends properly and then project it using some of the models that we already, the machine learning models that we already have, they are going to be very important in industry. They are already being practiced in industry to a large extent. So it will be with us. But even artificial intelligence requires intelligent people. So if a student is intelligent, if she learns the technique, if her basics are clear, then obviously she will be at an advantage of using these models, using these machine learning models to predict something. Because you can use any model, and in some of the cases, they are simply giving garbage. So to discern between what is realistic and what is not, you need to have your fundamentals clear. So by all means, artificial intelligence, machine learning, they are the tools of the future. But the tools in the right hand is the most important thing. So you learn your fundamental, the students should learn their fundamentals first, use all the tools which are available, and then to predict a better future. So yes, it is going to be there, but to decipher the results and to pick the right one requires some sort of intelligence and thinking. And that we have to do, the students will have to do. So as long as they are confident that they know the process and whatever be the predictions they're getting is doable, is realistic, then there's a lot of cutting of time, effort, money, competition. So these are the advantages which we have to choose judiciously and to apply.
So would it be wrong to say that the brightest prospects, not just in chemical engineering, but in any core engineering discipline, would belong in the future to those kinds of students who have a core expertise in their respective disciplines, and in addition to that, would have some sort of a specialized knowledge in artificial intelligence and machine learning to be able to apply those things in their core discipline. So
I partly agree. Yes, that is something which I think an employer would look for, that someone whose training is complete and someone who knows how to use these, how to get results, and so on. But there are certain these will become routine after some time.
yes.
That is what I think. That it's a novel idea now. So people are applying it to many different areas and getting exciting results, or reducing the time and everything else. But once it gets mature, then anyone would be able to use them. And the scope of interpretation will become limited. So we have to keep on exploring new areas in which we can effectively apply these techniques. Now, one way of creating new areas is that if you have something, new concept, new idea, new process, new materials, so if you contribute in that, then you will always be relevant in the job market. Merely just that you know artificial intelligence will only take you this far. But the moment you know that how to do something new and then apply artificial intelligence or any other model to predict the future, that is something what I guess employers of tomorrow will look for. Not just that routine application of AI or machine learning in some set areas. So fundamentally, nothing beats innovation. So if someone can innovate, he or she is going to be the most prized possession of any industry, of any university, in any profession. So innovation is the most important thing. And to project the innovation using the tools, therein comes your machine learning.
And that always comes from the core knowledge and fundamental knowledge.
Absolutely.
Thank you. Thank you. So we have already talked about AI. We have already talked about the various kinds of fundamental knowledge which a chemical engineer would be prepared in. But beyond these things, what kind of skills do you think a student needs to develop during his undergraduate years in order to be successful in the future? So beyond his official training, his or her official training, what kind of things? It could even be like development of interpersonal skills, because engineers always have to talk with other engineers, prospective clients. This could also be a skill. So what do you think?
You have touched upon a very important point. You may have new ideas, but if you cannot sell that idea, if you cannot package that idea, if you cannot make other people understand how important this idea is going to be, then everything is futile. You may build something, but people have to understand, people have to appreciate. You have to make them appreciate through your presentation, through your way you are explaining things to them. In obviously, depending on the audience, your pitch is going to be different. That we do all the time. But fundamentally, what I think is interpersonal skill is very important, because you are not going to work alone.
Yes.
Whether it's in industry, you're going to be part of a team, and you have to have a cordial relation. You have to be well accepted, and you have to be someone whose opinion is going to be of value to the team members. So unless they respect you for your knowledge, for your expertise, and for your willingness to work with others and help others, and be appreciative of others' efforts, you will never be a team member. And you will not get the full cooperation from your team, not full support from the team, because you won't be able to solve everything on your own. You need certain inputs from your teammates in order to build something good. So interpersonal skills, presentations, that are going to be extremely important. It is also going to be true if someone decides to go for higher studies.
Absolutely.
Because we alone cannot do much. Okay, we have to have proper collaborations, uh, in areas where interests uh, coincide with each other. Okay, there is some sort of overlap, and we have the respect of each other. Unless we do that, then that's also going to be extremely difficult. So presentation, appreciation of others' work, the way to lead a team, the way to be a part of a team, these are certain things which the training at IIT would impart on our students. But ultimately, it is up to the students to learn and adapt to this style. So apart from that, what I think will be important is not everything is going to be taught in the class. Not everything is going to be taught in the course. Something that you are going to take an elective from computer science department or from material science department. So the ability to pick up new things and new ideas, how do you analyze them? How do you assimilate them and apply in a completely different domain? Because you're not going to compete with computer scientists. What your strength lies in understanding that and assimilating it to an existing process in which you are the boss. You know about it. So you learn, adapt, analyze, apply. So if we follow these, I think a student is going to be more successful rather than blindly getting into a computer science course in thinking that I am going to be better than someone who has done that for the past 4 years.
True.
So these different outlooks and would be very important to figure out from the very beginning.
So thanks a lot, sir. Finally, I would like to request you to put out a message to all the students who it seems like they are going to get chemical engineering or they are proactively choosing chemical engineering. So what would be your message to them beyond the research, beyond everything, as they are stepping into this through this threshold of chemical engineering discipline? What would be your message to them?
I would tell them, welcome to the chemical engineering department. Whether you are here by choice or because of this has been allotted to you, there is every opportunity for you to learn new things, to make yourself a complete. So you're entering here as an 18 year boy or a girl, and I hope, and I have seen it many times, when they leave, they become a complete person in terms of their knowledge, in terms of their overall growth, and in terms of their outlook. So come to chemical engineering, enjoy your studies. We are here to help you to achieve your goals, whatever that may be. And there are wonderful things in different facets of engineering and science that you can do from chemical engineering. So don't forget that. Be proud that you are going to be a chemical engineer. And there are very few disciplines who can be as versatile as you. You can be many things all at once. And the journey starts here in your first year at the chemical engineering department. So welcome once again.
Thank you so much, sir. Thank you for the beautiful words. I'm feeling inspired by these words now. Already in the work that we do, there's a lot of overlap with chemical engineering, and that is one of the golden things about chemical engineering. So I, as a mechanical engineer, feel some sort of an affinity towards chemical engineers. I believe in a similar way, there are other disciplines also who feel a sort of affinity towards chemical engineering. So please correct me if I'm wrong. So in a sense, chemical engineering has inherently a very interdisciplinary spirit about it. So,
Absolutely.
yeah. So
Absolutely.
I think anyone who joins here, if not anything else, he or she is going to have an absolutely exciting time.
Yes. But there is a Chinese course which says that may you live in exciting times.
Oh, yes.
How you are going to have this exciting time is up to the students.
Yes.
You use the opportunity to its fullest. And definitely, not only you are going to have an exciting time, you are also going to have an enriching time, which will last you for the rest of your lives. So to the students, once again, enjoy chemical engineering, come to us. We'll be happy to have you with us for the next 4 years, 4 or 5 years.
Thank you. So with this, we end this discussion. It has been absolutely riveting to listen to your words. And from my side also, all the very best to all the students who are going into chemical engineering. Thank you.